Let us take a look at how to find the product of the roots of quadratic equations. We're going to start off by looking at the standard quadratic equation, then we'll examine the roots of a quadratic equation. Then I'm going to show you how to actually derive the product of the roots of quadratic equations. Once we're done with that, we will look at the steps that we can use consistently to find the product of the roots of quadratic equations and then apply those steps to some examples. So what is the standard quadratic equation? It's always expressed in the form ax squared plus bx plus c equal to 0. Remember that this is your quadratic term, this is your linear term, and this is your constant term, and you always have to make sure it's equal to 0 on the right hand side. Now, what are the roots of the quadratic equation? The root of a standard quadratic equation is, and when I say standard quadratic equation, it means that it's expressed in the form ax squared plus bx plus c equal to 0. And so the roots are going to be negative b plus or minus the square root of b squared minus 4ac over 2a. Remember that this means that this plus minus here means that you have two possible solutions to a quadratic equation. So now, how do we go about finding or deriving the product of the roots of a quadratic equation? So what I'm going to do here, we start off with x equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So let's assume that the first root is alpha. Alpha is equal to negative b plus the square root of b squared minus 4ac over 2a, and then we can call the second root beta, which is equal to negative b minus the square root of b squared minus 4ac divided by 2a. So the product of the roots is going to be alpha multiplied by beta, so that is going to be negative b plus the square root of b squared minus 4ac over 2a multiplied by negative b minus the square root of b squared minus 4ac over 2a. So if you look at this, we can look at this as let's have a sidebar here. A minus b multiplied by a plus b is a squared minus b squared. So what we're going to end up with is, when you multiply this, let's go ahead and we'll multiply the numerators together and then multiply the denominators together. The numerators look like something in the form of the difference of the factors of a difference of two squares. So because you have a plus here, you have the same term on the left side of the plus and the same term on the right side of the plus, and then you look at it here as for the minus as well. The term on the left side of the plus is the same term on the left side of the minus sign, and the term on the right side of the plus sign is the same as the term on the right side of the minus sign. So we're going to end up with a situation where we have a difference of two squares. So it's going to be negative b squared, and then we're going to have minus, and then let's go here and we have the square root of b squared minus 4ac. We're going to have that squared over 2a, and then we're going to also square that. So this is going to give us b squared minus, let's go with b squared minus 4ac divided by 4a squared. So when we take this out, we're going to end up with b squared minus b squared plus 4ac divided by 4a squared. This is going to end up becoming 0. So we have 4ac divided by 4a squared. So we cancel this. This is going to cancel out. This a is going to cancel this one out here. So the product of the roots is going to be c over a. So alpha multiplied by beta is equal to c over a. So now let's go about looking for How do we go about calculating the product of the roots of quadratic equations? We're going to first compare with our standard quadratic equation, ax squared plus bx plus c equal to 0, and then we'll find the values of a, b, and c, and then we will substitute those into this equation which we just derived, and so we're going to find c divided by a. So let's try some examples. What is the product of the root of 2x squared plus 9x minus 16? So we have ax squared plus bx plus c equal to 0. And so a is equal to 2, b is equal to 9, and then c equal to negative 16. So alpha multiplied by beta is c over a, which is negative 16 over 2, and that will give you negative 8. The next example, we're going to do the same thing. Ax squared plus bx plus c equal to 0. A is equal to 16. B is equal to 0. Notice we have no value for b here, so that's going to be 0. And then c equal to negative 49. So alpha multiplied by beta is c over a, which is negative 49 over 16. Whenever you're in algebra, you don't have to write things in a mixed form. You can leave it in this form. It's going to be acceptable by most algebra teachers. And then finally, we have this example. We're going to do the same thing. Ax squared plus bx plus c equal to 0. So a is equal to 5. B is equal to negative 9, C equal to 10. So alpha multiplied by beta is C over A, which is 10 over 5, and this is going to give you 2. And so that is the product of the roots of this quadratic equation.